Alright, so here we're going to do 1939, okay? And we're just going to start with A for now and say, how would I synthesize compound A from benzaldehyde? So this is benzaldehyde, and I'm looking to make this molecule. Okay, this is not particularly easy to do at all, okay? Because effectively what I need to do is add one carbon. And there are not that many ways that I can add one carbon, but since we're in the chapter of carbonyl chemistry, it's worth noting that we can add one carbon, or one carbon synthon is what we call those, by adding formaldehyde to a Grignard reagent, okay? And that was something that we've seen in a number of cases. We don't have, if we do add formaldehyde to a Grignard reagent, what that gives us always is a primary alcohol. Okay, we don't have a primary alcohol here, but what we can start by envisioning, again, if I identify that I'm adding one carbon, that's step one. Step two is saying, what are the ways I know to add single carbons, and one of them is by formaldehyde addition. And I can say that knowing that formaldehyde addition gives me an alcohol, I now have to say that even if I don't have an alcohol here, I can envision that this guy came from this primary alcohol, okay, and that this primary alcohol product could have arisen from now a Grignard addition of benzyl Grignard over here plus formaldehyde. I can always check in the forward direction, see that this would in fact give me a primary alcohol, and that this primary alcohol, if I oxidize it carefully with DMP, will give me this aldehyde. Now the question becomes, how could I have formed this kind of Grignard from benzaldehyde? Well, this Grignard could have come from this benzyl bromide by adding magnesium metal. Now effectively we've simplified this problem to say, how do I make this benzyl bromide from the reduction, or from benzaldehyde? Okay, and that's really a two-step process. In the first step here, what I say is that this guy could have come from benzyl bromide could have come from the alcohol, alright, and that alcohol could have come from benzaldehyde. In the forward direction, starting with benzaldehyde, I reduce it with sodium borohydride to form this OH. I can convert this primary OH to a primary bromide by treatment with PBr3. I can now convert that to a Grignard reagent by adding magnesium and ether. From there, if I add formaldehyde, it gives me this alcohol, and then DMP gives me the desired product. So this is a lot of steps in our head now. Again, to look at this and say, 1, this is a 1 carbon addition. 2, I can do 1 carbon additions by formaldehydes. 3, formaldehyde products are alcohols, the addition of Grignards to formaldehydes. Alright? 4, alcohols can get oxidized to carbonyls. 5, how do I generate a Grignard? From benzaldehyde in theory, and going through all of these steps to get back to benzaldehyde, and then putting it all together in this kind of forward reaction pathway. I'm going to do the next one here, which asks, hold on, let's see if we can find that easily enough. Can I do this compound? Can I take, let's see, benzaldehyde and form this enamine, okay? So here what we're doing effectively is we're adding 1 carbon, and we're also forming an enamine. This enamine could easily have arisen from the addition of this secondary amine to acetophenone, so this ketone over here. And this ketone in turn could have come from the oxidation of a secondary alcohol. Alright, now the question now becomes, how could I form this secondary alcohol from benzaldehyde? Well, that hopefully is more straightforward, because I know that if I take an aldehyde and I treat it with a Grignard reagent, I will form a secondary alcohol. So again, I can put that all together now, and in the forward direction say, starting with my benzaldehyde, I add methyl Grignard plus acid in the second step. I get this product. I can oxidize that to the ketone, and then I can do enamine addition to secondary amine addition to this ketone under acid catalysis to generate the desired enamine. Alright, so that's B here. C asks us, where is C? I want to form this compound here, this alkene, from a Wittig reaction, from benzaldehyde, and that's pretty much clearly a Wittig reaction. I can take this alkene, break it down the middle, simplify it to carbonyl plus Wittig reagent. I can try to do it in the other direction. What I mean by that is putting the carbonyl on this side of the molecule and the Wittig reagent here, although that's going to give me now a secondary bromide that will not be amenable to nucleophilic attack, so that's why I'm better off breaking the compounds apart this way. When I break them apart this way, I can now say that this ylid, this Wittig reagent, came from an alkyl bromide, okay? And this bromide now could have arisen in turn from the benzaldehyde, okay? In the forward direction, what that means is I take benzaldehyde, reduce it to the alcohol, PBr3 brominate, use this to make the Wittig reagent, and then treat that with cyclopentanone to give me now the desired final product. Alright, so that's now, I think, going to conclude now 1939 and solving that problem.